the SI Pass session started this Tuesday, and they're continuing every week through Dev Week. So we have our schedule up on the board again. We really encourage you guys to come. It'll really help you. I know so far a lot of the information is basic and easy, but as CHEM101 progresses, it's going to get a lot more difficult. So we highly encourage you guys to come. Just a reminder, it is anonymous, so Dr. Farsi doesn't know if you guys attend or not, but it will definitely benefit your grade and your understanding of this course as a whole.
And if you continuously attend the course starting now, or the session starting now, then you'll be able to build on that learning instead of right before an exam having to learn all that information. It really helps. But if you didn't get a flyer or you lost yours when we handed them out last week, they're right up here for you to see. Thank you.
Thank you guys.
Any question about SI Pass? Okay. So let me go to the lectures or slides that So before I start the lecture and figure out how to upload these files, insert. Okay. It's working now and it's recording. Okay. Before I start the lecture, does anyone have any questions? About the homework assignment, lecture, everything's good? Okay. So first I want to make an announcement. Can everyone hear me well? Okay. So you will be having your labs starting from this Monday. And some students last semester, they had confusions that these lab and the class are the same. Maybe for some of your courses, the lab will be part of the course, but in this class, or like for chemistry, CHEM101 and CHEM101 lab are like two different courses. So the lab has 1 credit, the course is like 3 credits, they are completely separate. So treat them as like different courses. And also they have like different, courses. So you have like 2 courses on Canvas. One of them is the lab, the other is the lecture itself. That I'm going to upload everything you need to know about the lab on Canvas this weekend. But I thought to also, because most of you have both the lab and the course, some of you might not, but most of you, like 90%, have like the lab and the course at the same time. So I thought to now that I have you guys here, I also make some announcements about the lab. And I'm also going to go to each lab section myself next week to make sure everyone in the lab knows these things. But I just like briefly mentioned them here today. So the nature of the lab is to, in the lecture class, I just lecture you for like 50 minutes. It's just me talking, but you cannot run any experiments and learn the materials, experimentally. So the lab, the purpose is that you go into the lab, run some experiments, and see the cool things that you are learning in practice. So for that matter, you should attend the lab, right? For the course, if you're like sick or like that you have like excused absence, you can watch it online. But for the lab, you cannot run the experiment at home. Most of you don't have like the materials, you don't have like the instrument, equipment. So the nature, you should attend, for the nature of the lab, you should attend the lab. But things happen. Maybe, you get sick, you get COVID, you cannot go to the lab. For that matter, you can have 2 excused absences without affecting your grade. But that doesn't mean that you can, one day wake up and say, I don't feel like going to the lab. She said we can have 2 absences. That is not an excused absence. So excused absence means that, you couldn't make it to the lab for an excused reason, right? So you can have 2 of those without affecting your grade, meaning that, and I explain the next slide too, that I just don't consider that lab as part of your grade. Is that clear? So you should let me and your TA, specifically for your lab, the TA is your primary instructor. I supervise the TAs, I have weekly meetings, I just make sure they know what they're supposed to teach you. And if you have any concerns, I make sure that they communicate that with me. But you'll most of the time see them in the lab. And they give me your grades. So if you talk with me about excused absence but not the TA, if they don't know, they just give you 0. So you should make sure that let your TA know that you cannot make it to the lab. Also, although you have like 2 excused absences, I advise you to make up for each lab that you cannot attend, because this is life, things happen. Maybe you get food poisoning on 1 week, right? And then you say, okay, I have 2 excused absences, I take advantage of that. And then you go to a conference for the other one, and then at the end of the semester, God forbid, you get COVID. And now you miss 2 other labs too. So for 2 of them, I just don't consider those. For the other 2, you get 0, although all of them are excused. So if you can make up for the lab. Does that make sense? Because you don't know what is going to happen next. Okay. So I also put here to emphasize on excused and unexcused absence. So for the first one, if I can make this pen work, so you have like 12 labs total. Each one is 25 out of 25, so it could be out of 300 total, right? So for the first one, if you just don't show up to 2 labs and don't communicate that with your TA, don't have that excuse, you get 0. So you get a D on the course. And if you have like lower performance on the other labs, you may fail the course. But if you have the absences excused, you see I just eliminated lab 10 and lab 11. So you get a B. You know what I mean? So make sure to have your absences excused. Last thing I'm going to say about the labs. And I come to the lab section. As I said, I know some of you might not have the lab, and I apologize for just like talking 5 minutes if you don't have the lab. But I thought now I have most of you that have the lab, so I talk about this. And I upload all the experiments, necessary information, lab schedule, everything on Canvas this weekend. So you have like the required information. Any question? Good? Okay, let me see if the pen is working. And that is the, okay, so homework 1 review. I just wanted to do that on the Canvas itself, but I thought it takes me some time to switch between like the HDMI and this computer, so I just copy pasted everything here, So, because these things are really important throughout the course, I thought it's important. So first of all, my office location, ran through 001. Some students, confused. I know, lots of 0 and 1s. So it's like basement, like downstairs, like to the right? And email address, is lidafarsi@ui.edu. I know the traditional email at UI was like lfarsi, but I wanted my full name. So this is my email address. Make sure to know that. And this question everyone knew, so I'm just not going to spend time on that. And this one, if you have like more than 6 unexcused absences, 2 students thought that nothing happens. No, something happens, and that is you fail the course. And the reason that I do that is that, my main aim in this course is for all of you guys. Learn chemistry, that is my main motivation. And if you're not feeling well, stay home, and you can have more, you can have excused absences, even more than 6. Unexcused absences means to not come to the class, and don't tell me you cannot come to the class. Basically not caring. Does that make sense? Okay, and then the deadlines for like homework assignments and quizzes. This is, as I said, typically that we have like, if you go to the course syllabus schedule, you see exceptions, but typically homeworks are due on Wednesdays and quizzes are due on Fridays. Does that make sense? Any questions? Okay, and this question, everyone got it right. So again, I'm not spending time on that. And the same thing with this. Just like, I have like in the syllabus, Riley and Sydney's like schedule for SI Pass. If you didn't answer this question right, just go look at them and make sure to take advantage of them. Because I know these students are like top students and they know chemistry well and they attend each lecture, so they know exactly what I'm talking about. I give them like the homework assignments, the quizzes, your exams, and I ask them to solve similar problems for you. I also gave them the previous year's quizzes and homeworks, and also the exams. So they know what you're going to see in the exams. So I encourage you to go to them and ask them questions. And here, again, you can like go to tutoring, you can make appointments, or you can just show up at these times that are listed, and you can have online tutoring, and all the options were correct about the tutoring. Again, in the course syllabus, you can go and then find all these information. Okay, so if you cheat on an exam, you automatically fail that exam, meaning you get a 0 on that exam. So you don't fail the course, but you fail that specific exam. But if they catch you cheating like the second time, it has like more penalty, and I should go to university officials, let them know, and then it can have really harsh consequences. So just simply don't do that. And then this question, the other thing is that when I ask you a multiple choice question, read all the answers, even if you're 100% sure. So you read this question and you see, cheating. You said, okay, this is the answer. Read the other answers because of this, I'm sure most of the students that answered this question wrong, they just saw one option that was like the correct, and then they moved on. Read all the answers, even if you're 100% sure. Does that make sense? Okay, so final exam for CHEM101. This is on a different date as our class time, and a slightly different timing, 12:45. So be mindful of that. And I keep reminding you of that. And for the in-person exam, you should have a calculator, right? And as I told you at the first session, as long as you just do like, multiplication, like division and power, like simple mathematical operation is fine. And if you bring like more advanced calculator to the class, make sure don't cheat, don't program something on it, but you can use any calculator you have and then something to write on, And your in-person exams would be like multiple choice questions. I give you a Scantron, so I advise you to use a pencil so you can erase your answer if you answer the question wrong. Does that make sense? Okay, so all common substances are ultimately composed of tiny particles named atoms. As I teach you in the next lectures, you see that we have some compounds and some matter that they are not composed of molecule, but all of the matter, they are composed of atoms. And then we have like different sorts of compounds, and we talk about them in more details as we go along with the course. And then scientific method is a way of learning that emphasizes observation and experimentation. If at any point you have any questions, just ask me, okay? And then make sure, as I said, you are welcome to use all your notes, course materials, internet, everything for your homework assignments and quizzes. But when you're done with those, and when I upload the solutions, make sure you know the solutions, because in your in-person exams, you cannot use any resources. It's just you, your calculator, pen, or pencil. Okay, so a hypothesis is a tentative interpretation or explanation of the observations. It's not theory, it's not a law, right? So just a tentative interpretation is a hypothesis. We need to work on them more in order to develop scientific laws or theories. And which of the following is not true? Reasoning determines the validity of laws, hypotheses, and theories. Is that true or false? Why is it false?
You want to run experiments to test it for reason.
Exactly. So if I gave you a sentence and I claim something, and I give you some reasoning, that's not enough. I should run some experiments. I should give you some data based on experiments to see whether or not a law or hypothesis or theory is correct. Okay, what is the other name of models? Theories. Okay, don't confuse this. As I said, I always ask this question in the exam. I probably give it again. So models are theories. And fill in the blank with the best words. The scientific method begins with observation, and the laws, hypotheses, and theories are developed based on those observations. Okay, so that, and also fill in the blank with the correct word. What law states that matter is in a chemical reaction is neither created nor destroyed? Yes, right? So don't, confuse this. We're talking about like matter. So it's law of conservation of matter or mass. So is the following statement true or false? Atoms are so small that a single drop of soda contains 1,000 atoms. False, right? It was like 1 trillion billion of atoms. If I just give you like 100 or like exactly 1,000, that is false. Okay, so we already kind of reviewed the previous lecture, but also I thought it's good to kind of like have more class engagement. So true or false? Chemicals make up virtually everything we come into contact with. True. Chemists use reasoning to understand the world. Why?
Because they use kind of a big test or I can't say it.
Yeah, you're right. Scientific method, right? That it starts with observation and then they do experimentation. So they use scientific method. Fill in the blank. Is the tentative interpretation or explanation of observations? Hypothesis, great. Hypothesis. A good hypothesis is always correct, which means future testing should not prove it wrong. False, right? Because even like theories or scientific laws, they may be proven wrong, and hypothesis is even like less rigid than those. It's just like a interpretation. They are highly controlled observations designed to validate or invalidate hypotheses. Experiments, right? Is a brief statement that summarizes past observations and predicts the future ones. Which one? Scientific laws, right? So these are like scientific laws, and that's why I included these here, because these gets tricky, So scientific law, summarizes past observations and predicts future ones, but the other ones which are yes, models or theories, right? Both of them are correct. Theories or models provide a broader and deeper explanations for observations and laws. So this is the difference. Scientific law, I tell you, that I have this book here. It stays still until I exert force, or like my pen stays still unless I drop it, to exert force. It's scientific law, right? But theories give me like more explanation and tell me why that happens. They provide deeper and broader explanation for observations and laws. Scientific laws are also called models through truth. So what are called models? Theories. Exactly. Theories. Okay. Any questions so far? Good? Okay, standard agreed on quantity by which other quantities are measured. Unit, right? By themselves, number give us all the information we need to know. True or false? Right? If I tell you that I walked 10, what do I mean? Is it 10 steps? Is it like 10 minutes? Is it like 10 feet? Is it like 10 kilometers? It doesn't mean anything. You should always include units. What are the most two common unit systems? Yeah. Metric, which is like the same as like SI units or International System of Units, or English system. Which unit system uses inches, yards, and pounds? Which unit system uses centimeters, meters, and kilograms? The most convenient system for science measurements is based on the metric system, yeah. And it's called the, exactly. So international system of units, or SI units. Okay, any question here? And all of these are available in the previous slides in your study guide that I posted, or for chapter 2 I'm going to post it soon, but the previous one for chapter 1 I already posted. Any question about any of these? And as I said, I'll already posted all the slides, and with that, yeah, you have all the information that you need to know. What is the base unit of length? Meter. What is the base unit of mass? Kilogram. Yeah, don't get confused. It's not gram. It's kilogram. Gram. What is the base unit of time? Second. Yeah. So just remember this. Meter, kilogram, second. I give you in the multiple choice questions in your homework, you'll see that what is the base unit of length? Meter, centimeter, millimeter, inch. What is the base unit of mass? Kilogram, gram, pound, you know? Or like what is the base unit of time? Second, hour, minutes, you know, light year, I don't know. So no, these are like the base units. So, but with those being said, these were kind of like review. I just wanted to make sure that all of you knew these materials. And now I'm going to start with the rest of chapter 2. So we talked briefly about like base units and derived units, and derived units are basically derived, as they say, from other units. So if I have like unit of length, which is meter, if I have it to the power of 3, it would be the unit of volume, right? So if I just say what is the, you know, length of this wall, if I bring, you know, a scale and like a meter and then calculate that, you know, that would be just unit of length. But if I multiply the length by height and the width, it would be the volume of this room. Does that make sense? And derived units are, you know, we did some mathematical operations on the base units and then we get derived units. And then we talked about like, you know, unit of volume. And then if I tell you that, you know, which one of the following is not a unit of volume, and then I say cubic meter, cubic centimeter, or like centimeter, which one? Centimeter, right? Because that is the unit of length, not volume. Is that clear? Any questions? Yes?
So like PSI, like pounds per square inch, that would be a derived unit?
Exactly, yes. So the question that your friend asked is like about PSI, which is like a unit for like pressure. And you know, I tend to not repeat the question, and people who are watching the lecture, they cannot hear what the person asked. So please remind me if I forget to repeat the question, so everyone that they couldn't come to the class, they can also know what was the question. But yes, pressure is basically force over length squared, right? So that units of pressure in general is a derived unit, or also like Newton itself, or like unit of force. And as we go along, I show you all these things, so don't worry about them. But as of right now, volume is an example of derived unit because it's be driven from the other units. Any questions? Okay. And here, your book listed some common units and their equivalents. In this course, I don't expect you to know any numbers unless I tell you so. So for instance, for prefix multipliers of SI units like mega, giga, nano, those things that we talked about, I expect you to know those. Or, as we go along in the other chapters, we have like some numbers that I need you to remember. But these numbers, none of these, milli, I expect you to know, that is like 10 to the power of minus 3. As I said, that's prefix multipliers. But these numbers I don't expect you to know. So don't worry about that. And my rationale for this course and all the courses that I teach is that if I don't know something by heart, I don't expect you to know. But what I expect you to know from this table is to know that what are the units or some common units of length. So kilometer, meter, mile, inches, yards, foot, inch, centimeters, right? Because if someone is talking to you, or like you listen to the news and they're talking about something and then they say, okay, this thing is like, you know, this much feet or like yards, you know, probably you're more comfortable with those units, right? Foot, yard, inch, English system, but maybe not that much with the SI units. So I expect you to know that if I talk about kilometer, I'm talking about length. Does that make sense? Or like meter, mile, inches, yard, centimeter, foot, inch. So I say which one of the following is not a unit of length. And I say kilometer, meter, foot, Newton. Newton. That is a unit of force, right? It's not length. But if you know units of length, you can just omit that option, even if you don't know what that is. Does that make sense? Okay, the same thing with mass, you know. So kilogram, pounds, you know, grams, ounce, they are like units of mass. And you know, for different applications, we use different units. So if you want to travel internationally and you want to have a suitcase, they say, okay, the suitcase can be like 22.5 kilogram, right? Or it can be like roughly, I don't know, 55 pounds, depending on the airline, right? So they don't use ounce, right? Or like grams when they want to talk about that. But then if you check like some price of precious metals, for instance, they say that, okay, the price of platinum or like gold is this much per ounce, right? So it's good that if you're talking about ounce, you know that, okay, they're talking about the mass. And something that usually people confuse is the mass and weight. Those two are like two different, you know, concepts, and they have different units. The unit of weight is like Newton, but the unit of mass is like kilogram. And then usually, you know, we use them interchangeably in like daily life. So we say that, oh, you know, I weight like 50 kilogram, right? Or like 100. So that is mostly with like at least kilogram and Newton. So you remember that when you're talking about, you know, how much you weigh, you're talking about the mass. So basically you're using wrong units. Does that make sense? So the unit of mass is kilogram or like pound, unless you're talking about like pound force. Is that clear what I'm saying? So when you're talking about your weight, you actually are talking about your mass. And then we talk, you know, I have like more slides later on that I talk to you in more detail. But as of right now, know that weight and mass are two different things. They're not the same. And then we refer to mass here. Okay, volume. We already talked about like, you know, cubic centimeter, and then liter. I have that in the previous slide. So liter, milliliters, cubic centimeters, and then quarts, liters, gallon. Those are like units of volume. And again, depending on what applications you're talking about, or like, you know, if you have like a, you know, large containers, you talk about like, you know, gallon. But if you have like, you know, a tiny amount of water in a container, usually just talk about liter, right? Or like if you run experiments in the laboratory, usually you're instructed to have like this much of like milliliters, right? Or like microliters, because you have a pipette and it has like a small amount. You're not talking about gallon. So depending on what application, you use like appropriate units. Does that make sense? Any question? Okay, I had like more. Okay, my mass is 50 kilogram, and then if I want to calculate my weight, I say, okay, weight equals mass multiplied by g. So I say 50 multiplied by 9.81. So if I just consider this roughly 10, would be 500 Newton. That would be my weight. But my mass is 50 kilogram. Does that make sense? Yeah, great question. Any other questions? Okay, so don't confuse weight with mass. So now to give you guys a little break, let's do the class attendance. And that is like the link that I included on top. The bottom one is just like I got the picture from that website. So in order not to do plagiarism, I included the link to that. But the SurveyMonkey one is the class attendance. And if you have any difficulty or couldn't figure it out, just, raise your hand and let me know. Because after the class is done and I post a lecture online and the slides online, anyone can just say they were in the class while they weren't. So make sure that let me know during the class time. And make sure to write your full name. I only can see this survey, so don't worry about the security of that. So.
Every time I go to search it, it's just kicking me out, so I put in the,
Can you just get it like
that's what I did 2 times. Oh, search is just kicking me out, so.
Oh. Oh, okay, sure. Let me just like bring pen and so like what do I have here? Okay. Anyone else who had difficulty that they couldn't put their name? And make sure that you press like OK, done, so I could see your name. Everyone's good? Okay. So let me move on with the lecture. Any question about anything that I talked about? Everything's crystal clear? Oh, yes.
So what did you say you use Newton meters for back on like the weight and mass difference? I just use kilograms.
Okay, so the difference between mass and weight? Yes.
Because you're saying something about Newton meters and kilograms.
Uh-huh. Yeah, so you see that force is in general equals m multiplied by a, which m is mass and a is like, so acceleration. I had like the Farsi word like shetab, we call it in Farsi. Anyway, so the equivalent, so F, you can depict it with W, like as an abbreviation for weight, right? And weight is some sort of force, right? And you can write M multiplied by G, and this is like the gravitational force, or like gravitational constant, I guess you can say. So all of us, or like everything that we are on Earth, and then there is like a gravitational constant, or like gravity. We are all in the gravity of Earth, that the number is like 9.81. Then you can, then it can be Newton per kilogram based on the equation. So any mass, because we're on Earth, we are under Earth gravity, and then if I was in Moon, I was under influence of Moon's gravity, right? And depending on that, there is a force being exerted on all of us, and that is like because of the gravity. Does that make sense? So that is basically weight. So if I, for instance, here, if I tell you that, okay, I weigh like 50 kilogram, that is wrong. As I said, my mass, or maybe let me go to this. Okay, so now we want to talk about scientific notation. So you will encounter in this course and also several other courses and in the news that sometimes we deal with really, really small numbers or really, really large numbers. And it's just like really difficult to address those numbers, as if I want to write, for instance, this number here, it just takes me forever to write zeros, and then I should count them, that if I put like enough zeros, or the same thing with the really large numbers, So scientists, to prevent confusion and like save time, they came up with scientific notation. And in order to write a scientific notation, basically we write a number between 1 to 10. So 1.2 is a number between 1 to 10, correct? Right? So remember, when you want to write a scientific notation, you should have your number written between 1 and 10. So you won't be writing like 12 points. So you have like the number between 1 and 10. So you should write 1.2. So this is the first thing to remember. The other thing is that you use a decimal point, and then you will be having a decimal part. Okay? And you also will be having an exponential part. And do you remember how to work with exponentials? So you have like a base, and you have an exponent or power, right? Here we call this number here base. This one over here is the exponent, or like the power, right? So, and I also included some videos, the link to some videos. If I have time, I go through them in the class, but probably I won't be having enough time. So a positive exponent, these are kind of like review, means 1 multiplied by 10 n times. Meaning that, first of all, do you remember that any number to the power of 0 is 1? Do we know that? So any number to the power of 0 is 1. It's just a rule. And 10 to the power of 1 means that I multiply 1 with 10 one time. 10 to the power of 2 means I multiply 1 with 10 two times. So in general, if I tell you 10 to the power of 4, it would be like 1 multiplied by 10 multiplied by 10 multiplied by 10 multiplied by 10. And already you see why we use powers, because it just saves us time. Instead of me writing 10 multiplied by itself like 4 times, I just write 10 to the power of 4th. Or 10 to the power of 4, sorry. Is that clear? Okay. And then negative exponents means 1 divided by 10 n times. And here, for instance, 10 to the power of minus 1 is like 1 over 10. And then these power rule, now we're talking about numbers when the base is 10, but it's the same thing with the, like for instance, 3. If I say to you, what is 3 to the power of 2? You say that, okay, I have like 1 multiplied by 3 multiplied by 3. And in general, 1, if it will be multiplied by any number, it would be like, it won't be having any effect, right? 1 multiplied by 3 is 3. So in general, if I ask you what is 4 to the power of 3, can anyone tell me how to write this? And you can also not write 1 because it doesn't have any effect. But in general, the power saves us from writing like several multiplications or divisions. Does that make sense? So what is 5 to the power of 2?
1 times 5 times.
Okay. And now here, for scientific notation, we are dealing with 10. So that's why your book is talking about tens only. But the powers can be with different bases too. So 10 to the power of minus 2 means 1 divided by 10 multiplied by 10, which is like 0.01. Or like 10 to the power of minus 3 is 1 divided by 10 multiplied by 10 multiplied by 10, which is like 0.001. Any question about like these things? Good? So what is 10 to the power of minus 5? Can you yell that at me?
1 then times 10 times 10 times 10 times 10 times.
Right? So you make sure you write it 5 times. 5 times. And if I want to write it in decimal points, what should I write?
0.00001.
So you start counting after decimal. You should have 1, 2, 3, 4, 5. Does that make sense? So for instance, 10 to the power of minus 3 would be like 1, 2, 3. Here would be 1, 2, 3, 4, 5. Minus 2 would be like after decimal point 1, 2. Good? So now, as I said, I may go back to this and then try to, show you this in the class, but I highly encourage you, if you have like questions, and then they Khan Academy in general, they have like really useful videos for like all subjects. So just click on the links and then watch the videos about exponents. And I wanted to do that during the class time, but it prevents me from like progressing with my lecture. So in general, to express a number in scientific notation, you do the following. Move the decimal point to obtain a number between 1 and 10. So if I tell you which of the following is the scientific notation for like 5 billion, and if I give you a number that starts with like 50 multiplied by something, you can just know that that option is wrong, because you should write the number between 1 and 10, right? Does that make sense? Okay. And write the result from step 1 multiplied by 10 raised to the number of places you move the decimal point. What does that mean is that, for instance, if you have like 5,983, so this number is as if the decimal point was here, right? So we move the decimal point and write the number between 1 and 10, right? So it would be like 5 point the rest of the number. So I move the decimal point here. So it says, write the number from step 1 multiplied by 10 raised to the number of places you move the decimal point. So you see that here the decimal point was here, and then I moved it here. How much did I move it? How many places? 3. So I have like 10 to the power of 3, right? And I write 3 here. Or like here, for instance, for this number, the decimal point was here. I write the number between 1 and 10. So it would be 3 point the rest of the number. I count, I changed it here. 1, 2, 3, 4. So it would be to the power of 4. And then the next step tells us negative or positive. But so far, any questions? Clear? Good. the exponent is positive if you move the decimal point to the left. So here, you see the decimal point was here, I moved it here. So I moved it to the left, so the exponent is positive. The exponent is negative if you move the decimal point to the right. So the exponent, the decimal point was here, I moved it to the right. So the number here is the negative. So that is -4. Does that make sense? And in general, remember that when you have large numbers, they have positive exponents. And when you have really small numbers, they have negative exponents. Because, if I have like 10 to the power of -3, that is basically 0.001. So small numbers have like negative exponents. But if I have like 10 to the power of 4, 1, 2, 3, 4. Large numbers have positive exponents. And when I don't write positive sign, it means positive, right? Any questions? Okay. So now I start significant figures. And that means writing numbers to reflect precision. So in general, let me first talk about precision. So when you go to experiment and then run some experiments and then do some work, or if you want to report any number, you should also report the precision. And how we do that is with significant figures, right? So for instance, if I tell you that my mass is 50 kilogram, so if I tell you depending on how many digits I put after this decimal point, that it means that much precision I have. So if I just only tell you 50 kilogram, so what is the range that the mass can be? Can you tell me? So if I tell you that, the mass is like 50 kilogram, does it mean that it can be 60? Does it mean that it can be like 50.1? It can be, right? So the number, if I give you this number, the number can be between like 49 and 51, because that is the scale I had. The precision was like to the 1 digit, right? So it's kind of like it can be 49 or 51. But if I tell you that, the mass is like 50, and then I put like another 0 here after a decimal point, can the number be 15.1 now? No, right? So this means that the number can be between 49.9 and 50.1. Does that make sense? Because the scale that I had could like measure this much of precision, right? So now I gave you an example about mass. Now, go to the book's example. In general, I tell you, and actually I was doing that like recently to measure my wrist, and I had a scale, and I was like, okay, it's like 5.5 inch, right? And then my scale could like give me one, decimal point, 1 point after decimal, precision. So if you have like similar thing here, if you look at this scale and then you say that, okay, this number is 24.6 millimeter, what that means is that these two numbers before decimal point here, these numbers are certain, and this number is estimated. So basically it can be anywhere between like 24.5, 1 digit less than 6, till 24.7. Does that make sense? Okay, and here, there are like some concepts that I'm going to ask you in your homework. So I'm just going to read them and review those for you. So scientists adhere to a standard way of reporting measured quantities in which the number of reported digits reflect the precision of the measurement. So if we have like more digits, we have like more precision. If we have less digits, we have less precision. And numbers, and I have still 2 minutes, so give me that 2 minutes. Numbers are usually written so that the uncertainty is indicated by the last reported digit. Right, like the examples that I just gave you previously. And here is another one. If in the news you hear the temperature increase is like 0.6 centigrade degree, it means plus or minus 0.1. So it can be as high as 0.7, it can be as low as 0.5, but it is not like 1 centigrade degree. And we report scientific numbers so that every digit is certain except the last reported digit, which is estimated. For instance, if I give you this number, we know that these digits, they are like certain, but 2 is estimated. And as I showed you, we can like deduct 1 or add 1, and then that would be the range of the number that it can be. Any questions? So I'm going to write your second homework assignment tonight, and hopefully I can post it tonight, but if not, by tomorrow morning you will be having that. And that's all I have, if you don't have any questions.